Hi students, welcome back to another section. Well, today we are going to check our first exercise, the third chapter, understanding quadrilateral. In that chapter, the first exercise. Well, the first question is given here are some figures. Yes, well, here they have given some figures, and what's the questions? Classify each on the basis of the following. So we have to classify these figures as the first one: simple curve, simple closed curve, polygon, convex polygon, concave polygon. We are already familiar with this concept, right? So we can just categorize these figures into this group, right? The first one, let us consider simple curve, right? Let us consider the simple curve. We know the simple curve means it should not cross itself. Such curves are called simple curves, right? So when we talk here, it is what? It is a simple closed curve. So we need to consider only simple curve. So it's simple curve. Yes, this is simple curve. This simple curve. This simple curve. This simple. It's not simple. It's not simple. It's not simple. Now come to the second. Second. What is second question? Simple closed curve. Simple closed curve. We have to categorize from here. So yes, here it's a simple closed curve. Yes, here it is simple closed. Here it's simple closed. Here it's simple closed. Here it's again a simple closed. Yes, rest all are not simple closed. So these are simple closed. Yes, well, now consider the polygon. Out of this category, we have to classify. We have to find out what are the polygons. So we know the polygons means it should be a simple closed curve made up of line segments only. So yes, here it's a polygon, right? Made up of line segments only, and it satisfies the definition of simple closed curve made up of line segments only. So it's a polygon. Yeah, here it's another polygon. Here no, it's closed itself. So yeah, here only these two are polygons. Well, now it's not a polygon because it is not made up of line segments only. See, here line segments are there, but the definition says line segments only, so we cannot belong this we cannot put into that category. Now consider this convex polygon. Convex means, you know, when we look at this figure, we know it's a concave polygon, right? So it does not belong to that category. But here it's a polygon, this and this. So here it's a convex polygon, and here it's a concave polygon. We can write like that. So okay, convex polygon and concave polygons. Hope you understood. Well, now let us move to next question, right? So the question is what? The question is, how many diagonals does each of the following have? How many diagonals? So what we have to do? So we have to draw a polygon. So here it's the first question, a convex quadrilateral, and second one, irregular hexagon and a triangles. So a convex quadrilateral we have to draw. Convex is very simple. See, here we can draw a square or rectangle. So how many diagonals it has? Just draw. Well, 1, 2. Is there any diagonal? More diagonal? No. So we can say it has 2 diagonals, right? So next, consider regular hexagon. We can draw hexagon. Hexagon means what? It's a polygon which has what? Which has how many sides? Hexagon, 6 sides. So we can draw 1, 2, 3, 4, 5, 6. It's a regular hexagon. It should be a same. The side should be in same length. So we can consider this as a regular hexagon. So how many diagonal it has? Just we can draw. The first one is this 1, 2, 3, 4, 5, 6, 7, 8, 9. See here? Yeah, we can say this much only. So we can say here we can draw 9 diagonals in the case of a hexagon. Now here is a triangle. Yeah, we already discussed that. We can draw a triangle. See here, it's a triangle. How many diagonal can we draw here? Yes, you said it. We cannot draw a diagonal because the diagonal means it is a line segment which connect two non-consecutive vertices. Here in the case of triangle, we cannot find non-consecutive vertices. Therefore, we can say in the case of triangle there is no diagonal. So 0 diagonal, right? Now consider the third question. What is the question? Yes, what is the sum of the measures of the angles of a convex quadrilateral? Well, this property holds if the quadrilateral is not convex. So what they are asking? So what about the sum of the measures of the angles of a convex quadrilateral? So we have to consider a quadrilateral which is convex. Let us draw here a convex quadrilateral, right? It is a convex quadrilateral. We can give name as AB, C, D. Yes, here it's a convex quadrilateral. We have to find out the sum of the measures of these angles. So we have already learned the angle sum property of a triangle. We know the sum of the measures of three angles of a triangle is 180 degree. So the same rule we can apply here. We can just draw a diagonal, and what happened at the time? It is divided into two triangles. Yes, here is a triangle 1 and here is a triangle 2. Well, now we know the upside, this angle plus this angle plus this angle, that should be 180 degree. Now consider the downside triangles. Yes, this angle plus this angle plus this angle, we know that is also 180 degree. Now what they are asking to us, what about altogether this quadrilateral sum of the angles, right? So we know that it should be this plus altogether this plus this angle plus this angle. Yes, we know that this plus this, that is this angles. So well, it should be what it should be, we can say 180 plus 180. So what about that? It should be 360 degree. Okay, so we can say in a quadrilateral the sum of the angles, it should be 360. If it is a convex or concave, whatever it is, the sum of the angles of a quadrilateral, we can say it should be a 360 degree. Now here is a fourth question. What is the question? Yes, examine the table. So we have to learn these tables, right? And what they are saying, yes, examine the table, and they are asking, what can you say about the angle sum of a convex polygon with the number of sides 7, 8, 10 and finally n. So we have already learned that the angle sum property of triangle is that we know the angle sum property of triangle, the sum of the three angles of a triangle is 180 degree. Just like that, we have just learned that the angle sum property of a quadrilateral, that is what when we add the four angles of a quadrilateral, it should be a 360 degree. Just like that, we are going to derive a formula of the angle sum property of a polygon, generalize the angle sum property of a polygon. So how we can derive it? It's very simple. Now consider the figure triangle, the first one. Number of side is 3. So angle sum property of a triangle is 180 degree. Now consider here is a quadrilateral. We just now only we discussed that here it's a diagonal. So it divides this into two triangles. So we can say when we add all together all angles, we know it should be what 360 degrees. So how we are getting that? Yes, that we are getting there are sides, 4 sides, so 2 into 180, that should be the angle. So how we are getting this 2? Yes, there is a relation what 4 minus 2. 4 is here, 4 is what 4 is the number of sides, 4 minus 2 into 180. Now consider the pentagon. Here there are 5 sides. Well, and here when we draw two diagonal, what we are getting? Here we are getting 3 triangles. So the sum of the angle should be 3 into 180. So the 3, how we can connect, how we can relate with the number of sides? Yes, that is 3 we are getting 5 minus 2. What is 5 here? Yes, it is a pentagon. There are 5 sides are the 5 minus 2. That should be the 3. Yes, 3 into 180. So what about in the case of hexagon? Yes, when we draw the diagonal, 3 diagonal, it divides, it split itself into 4 triangles. Well, so we can say number of sides 6 and the angle sum property 6, therefore it divides into 4 triangles, therefore 4 into 180, it should be the sum of the angles. So how we can connect that 4? Yes, of course, that is 6 minus 2. What is 6 here? That is it's a hexagon, that's why it is a number of sides. Well, now yes, you got ideas. So here we can say the answer now. Here we have to consider what a polygon with 7 sides. So how we can say the answer? Yes, it is the sum of the angles. Yes, the sum of the angles should be number of sides minus 2 into 180. That is a relation. So we can say that it should be 7 minus 2 into 180. Yes, what is that? It should be what? 5 into 180. So that should be the answer. So what about in the case of second B? Number of sides 8. So we can say B, n equal to, we can say n equal to number of sides equal to 8. So what about in the case of sum of angles? Yes, it should be n 8 minus 2 into 180. Well, it should be the answer 6 into 180. So here they are asking C. What about in the case of C? Yes, n number of side is what here, that is 10. Therefore the sum of the angle is what? 10 minus 2 into 180. Yeah, that is only we observed in that table, right? So we can write it as 8 into 180. It should be the sum of the angles. Now come to this point D, number of side n. Yeah, here is the general formula. We can derive that the sum of the angles of a polygon which has n sides, we can derive it as S equal to n minus 2 into 180. It should be the angle sum property of a polygon where n is the number of sides. So we are getting a polygon of 20 side, 30 side, 100 side, whatever it is. So we can easily find out the sum of the angles of that polygon. So it's very simple. What just check how many sides are there, and n value n minus 2, the number of sides minus 2 into 180. That should be the measure, sum of the measures of the interior angle. Well, so this is called the angle sum property of a polygon, right? Yes, here is for fifth question. What is a regular polygon? State the name of the regular polygon of 3 side, 4 side, 6 sides. Very simple. The first one, what is a regular polygon? We know, we already learned that regular polygon means what? A polygon which are equiangular and equilateral. It's called a regular polygon. Well, if you consider a triangle, if you consider a polygon, its all sides are equal and also all angles are equal, we can say it's a regular polygon. Well, hope you understood. Now here state the name of the regular polygon of 3 sides. Yeah, we have learned already 3 sided are equal. What about its name? Yes, you said it, that is equilateral triangle. And what about in the case of 4 sided regular polygon? Yes, that is very simple, that is square. We already discussed that. Yes, that is what the square. 4 sided regular polygon, that is called a square. Well, what about in the case of 6 sided regular polygon? Is there any specific name? Yes, we have not learned, so we can say that it's a regular hexagon. Simply hexagon means we know it's a 6 sided polygon. If all sides are equal and all angles are equal, so we can say regular hexagon. Okay. Yes, now consider the 6th question, right? So what is question? Find the angles measures x in the following figures. Here there are 2 figures. The first one A. Let us consider this figure. So here the interior angles are given, right? So x is not given. So we have to find out the x values. So we can use here angle sum property. Well, so here what is this? Yes, it is a quadrilateral. We know the angle sum property of a quadrilateral. The sum of the angles, the sum of the measures of the angles should be 360 degrees. We have learned already, so that we can apply here. So we can write by angle sum property. We can say by angle sum property. By angle sum property, we can write it as 50 plus 130 plus 120 plus x equal to 360 degree, right? Because of the angle sum property, we know that. So when we add these two, 50 plus 130, 180, 180 plus 120, that is 300. So we can write 300 degree plus x, that is equal to 360. Yes, then what about in the case of therefore x equal to, we can write it as 360 degree minus 300 degree, right? When we take this 300 to that side, should be minus. Well, so the answer we got it as a 60 degree. Well, so that is the answer. Now consider the second one, right? Now consider the B question. Yes, here x is not given, rest all angles are given, but here its exterior angle is given. We know the linear pair. What is linear pair? When we draw a line, straight line, and cross here, it's like that. We know this angle plus this angle should be 180 degree. That is linear pair. Well, because this is a straight line, when a line is crossed this line, straight line, we know there it's formed linear pair. That means this angle plus this angle equal to 180 degree. That concept we can use here, right? Here it's a 90 degree given. Therefore, this angle also we can say it's a 90 degree. Now we can say what? The angle sum property. Well, by angle sum property, we can write what? 90 plus 60 plus 70 plus x equal to yes, 360 degree, because angle sum property. How many sides? 1, 2, 3, 4. 4 sided. Angle sum property of a quadrilateral. Well, we can add this. 90 plus 60 will get 150. 150 plus 70 will get 220. Right? 220 plus x equal to 360 degree. So what about therefore x equal to? We can write 360 minus 220. What about 360 minus 220? Yes, that is 140. Right? So here is answer 140, right? Yes, here is the third question. Well, here also we need to find out the value of x. So first we have to consider what shape is this one. Yes, what is that? It's a polygon. Well, how many sides it has? 1, 2, 3, 4, 5 sides, right? So angle sum property of a polygon we have learned. So we can write it as a number of sides n equal to 5. So we know by angle sum property, what about the sum of the angles of all interior angles? Oh yes, it should be what? N minus 2 into 180. Yes. So what is that? Yes, we can say here n values is 5. So 5 minus 2 into 180. So what is that? It should be 3 into 180. What about 3 into 180? That is 540. Well, so its angle, when we add all together, it should be 540 degree. By angle sum property, we can say the sum of the all interior angles should be 140. From here we can find out the values of x. How? See here, all the interior angles are given here. The x, okay, here, but here outside exterior angle is given. So we can say what about this interior angles? By applying a linear pair, we can say this is what? This is 110, right? Just like that, what about this interior angle? It should be 120. The reason is what? By linear pair, right? So we can give here, we can write here by angle sum property, we can say that from here we can start 30 plus 30 degree plus here it is 110. Yes, 110 degree plus here it is 120 degree. Yes, here it is yes, x plus x equal to what we got? That is 540 degree. Yes, now we can add all these things. So 30 plus 110, 140 plus 120, that is 260. 260 plus x, that is 2x, we know, equal to 540. Well, now we can take this number to that side. So we can write 2x equal to 540 minus 220 is 260. So what is that? 540 minus 260, that is 440, 340. 280, right? So what about in the case of x here? X equal to 280 divided by 2, that is 140 we are getting. So here it's answer. Now comes the question number D. Yes, what about this? As this it has what how many sides it has? Yes, well, 1 2 3 4 5, there are 5 sides. Yes, we know. And also it's given here what these all sides are equal. We know this symbol is represented what these all sides are equal. Well, so here it's a 5-sided and all sides are equal. Well, so we can say it's a regular pentagon. So what about angle sum property? So we know that 5-sided, just now only we have seen that if it is a 5 sides, so by angle sum property we can say what? By angle sum property we can say the sum of the angles should be, all angles all together it should be 540. How we are getting? Yes, that's 5 minus 2 into 180, we are getting 3 into 180. Yes, we are getting 540 degree. Well, now you see here, this is what all sides are equal. Well, so it's here it's given x, so it should be x, this should be x, this all angle should be x. So let us consider, we can write x plus x plus x plus x plus x, it is 540. Well, now we know this should be 5x equal to 540. Therefore, what about x? X equal to 540 divided by 5. So 540 divided by 5. What is that? It should be 1, 0, 48. How many times 5? 8 times. So x value is 108. Yes. Yes, here is the 7th question, the last question of this exercise. Here some figure is given. So we need to find x plus y plus z. Right? Here this x, y and z. We know these all are exterior angles, right? So we need to find out the sum of the exterior angles. Well, interior angle is given, right? Here this is given, this is given, this is not given, right? But here to get this x value, we know by applying the linear pair we can write angle x as what? 180 minus 90. It should be 90 degrees. So we got x. And what about in the case of z? Yes, z we can write 180 minus 30. So that is 150. We got this also. Now what about in the case of y? So y we can say either we can apply the exterior angle property. That means what? The y should be the sum of this plus this. Okay. Otherwise, we can find out that this angle by using angle sum property, and later we can apply the linear pair, right? So I think it is easy. Y equal to 90 plus 30. What is that? So it should be 120. Yes, we got this all x, y, z. Now we can easily find out this one y. Therefore, x plus y plus z equal to 90 plus 150 plus 120. So what is that? Yes, that is 360. Well, so we got the values of x plus y plus z. Yes, now consider the last question. Yes, here is the questions. Here also we need, here it's given a figure, and here we need to find out the values of x plus y plus z plus w. That means we have to find here the sum of all exterior angle, right? So here it's given some interior angles. Well, here 60 is given. Yes, from here we can find out the z value, right? Here 80 is given. So from here we can find out values of y. Here 120 is given. So by applying the linear pair we can find out the values of x. And yes, one is missing. So how we can find out this angle? Yeah, by applying what? By applying that sum of the all interior angles. From there we can find out the values of this, right? Later we can find out this value. So it's better, I think, first find the values of this angle. We can give here at one angle p. We can give p. So how we can find out p? First, so we know it's when we consider this 1, 2, 3, 4, 4 sided, it's quadrilateral. So by applying angle sum property of a quadrilateral, angle sum property of a quadrilateral, we can say that is what it should be a 360 degrees. Therefore we can write p plus angle, this plus 60 plus 80 plus 120 should be what? Should be 360 by angle sum property. So we can write P plus, we just add this, all this, 120 plus 80, that is 200. So 200 plus 6, 260, well, that should be 360. Then what about P? Therefore P equal to 360 minus 260. So what is that? That is 100. Yes, we got the values of P by applying angle sum property of a quadrilateral. Well, now it's very easy to find out the x plus y plus z plus w. So before that, what we have to do? We have to find the x value. So we can write here x plus 120 equal to 120 equal to what? Equal to 180. What is the reason? Reason is linear pair. From here we can find out the values of x. X has what? 180 minus 120. What is that? It should be 60. We got x. Just like that, we need to find out y value. So what about y value? So we can write directly y equal to 180 minus 80. Yeah, 80. We'll get 100. So the reason is what? A linear pair. Here also linear pair, the reason. What about x, y, z? What about z? So here it's a z values. Well, here, yes. So we can write z equal to 180 minus 60. Yeah, 60. So what is that? It should be 120. Yeah, that's also reason is the linear pair. So we need to find out w. Oh, what is w? So here we can try 180 minus p, right? 180 minus p. What is the value of p here? Yes, that is 100. See, 100. So we got here the answer is what? Yes, that is 80. Now what they are asking to us, we need to just find x plus y plus z. We need to add all those things. Therefore y plus z plus w equal to 60 plus 100 plus 120 plus 80. So what is that? Yes, we know it's 360. Well, so the values of x plus y plus z equal to 360. Hope you understood. Thank you.